This conference will now be recorded.
Okay. So good evening, Padmini, and welcome back to a fresh new session on market risk modeling. And we were talking about the time series model development framework. So on one of the applications that we developed on linear regression, so one of the things that we kind of saw was that uh, that the linear regression was not being able to capture the nonlinear behavior in the time series data. So linear regression would be a very basic regression framework which we could use in our data for to just to be used as a very basic model, but that's not a very accurate prediction methodology or a prediction framework for the market risk models. So the market risk models would mostly rely on time series prediction frameworks or on Monte Carlo simulations, which we will be discussing over a period of time. However, given the type of data series that we have in a market risk model, time series models are always a very they are always a very reliable kind of a methodology, because we need to predict that how is it that the time that the price of a derivative is evolving, price of a mortgage-backed security or accredited obligation is evolving, and we would also want to understand alongside that how is it that this model performance or this behavior is evolving over time. So that is something that we had kind of seen, or that is something that we had kind of discussed. Now over a period of time, so over a period of uh, over a period of discussion, one of the things that we need to understand is that for predicting these values over a period of time, what should be the appropriate modeling frameworks, right? And over here we come across with the time series models. So one of the things that we see over here is that this Arimer class of models, or Arimax, or the arch guard, or the heteroscedasticity based models would actually play a very critical role in helping us predict the volatility in time series and so on. Now, if we think about risk minimization or risk management, as we think about as far as market risk models are concerned, right? So, as we would kind of think about that, so the key set of the key set of risks which arises as a part of this, or as a part of the market risk models, would be the volatility models, right? So it would be the volatility measures, and it is these measures with this measure which we would need we would need to understand how exactly does this volatility work, and how exactly is it that this volatility can be predicted, how is it that this volatility can be developed, and so on. So these are some of the important questions. So the entire source of risk which arises in a market risk setup would be the volatility in the prices, because it is this volatility in the market which creates the variation or the dispersion from the mean value. So very simply said, an asset with with volatility in it, right, is considered to be a more risky asset. So apart from the standing on from the point of view of the more riskier models, right? So what we would need to understand is that how is it that the predictions in those models would happen. So how is it that what are the error correction mechanisms that we would follow, right? So how is it that it is going to work? So this is something that we need to discuss in details. So a part of it we had already discussed in the last class, where we had kind of talked about the so we had a basic discussion on time series frameworks, and we had also kind of talked about so we had kind of talked about the random walk models, right? So we saw that the mean. So we talked about the scenario where all the movements were being driven by the random. So the movement in the time series was driven by the movement of the random error components, right? So that was one of the important things that we had kind of talked about in the last class. And for the random walk forest and for the random walk models, one of the things that we saw was that these random walk models will help us kind of predict the riskiness in the behavior of the borrower, right? So it would kind of give us that part. So it would help us identify the underlying mechanisms of the time series. So it would help us mechanism. So it would kind of help us identify the underlying properties of the data generating process that a time series would have, right? So from that perspective, we had already seen how how would time series work, and we had already talked about it while we were talking about the random forest. And from there, one of the key concepts which we had stumbled upon was was the fact that there was this concept. So one of the important things that we had kind of stumbled upon was the fact that like so was the concept of stationarity, right? So one thing that we saw was that the for the random walk models that we had, right? So the random walk models were essentially so they had a constant mean at y0, which was the initial condition, and then onwards the variance was driven by time. So it represented something where everything was absolutely a noise. So everything that we had worked on with was absolutely a noise, right? So that is something that we needed to understand. That is something that we needed to uh, take into account. So so standing from that perspective, or standing from that uh, aspect, the next question that comes out to us is that how do we model these time series, or how would we go about developing these time series models for us, right? So how do we go about doing that? Because that is something which is really important for us. So we need to understand the methods of the prediction. We need to find out the different examples of time series, right? And we need to understand the the key components which comprise of a time series, right? And in that attempt, one of the important things that we also need to talk about is the concept of stationarity of a time series. So how is it that a time series model that we are trying to build up, how is it that the time series models that we are trying to build up, so what or how do we assess the accuracy? How do we assess the optimal number of lags? How do we assess, like, to what lag should we consider the models, right? So these are some of the important questions that we need to kind of look into, right? So, so just let me clear this part of from here, and we'll kind of start with drafting the documentation on the thing. Okay, fine. So before I start off, one quick question, Padmini. So am I audible? Can you hear me? Padmini, you are not audible.
Can hear you.
Okay, you can hear me, right?
Yeah.
Okay, perfect. Fine. So let's start on with this documentation on the time series models. So talking about, so the first question that comes out over here is that while I talk about time series models, so how do I represent a time series model mathematically? How do I, what would be the model specification, right? So right at the beginning. Right. So obviously, in order to answer this question, one of the important things that we need to understand over here is that to understand a time series model or a time series prediction, we need to understand that what are the factors which is causing or which would impact the prediction of a variable y at a given time point, right? So if I'm trying to predict the stock prices to let's say one month down the line, I need to understand that what all factors will actually be causing or would actually be influencing the the stock prices, the price of the asset at that point of time t, right? So this is one of the important points that we need to look into. So over here, so let's say I have uh, so I have a sequence of points because time series is nothing but time series is a sequence of random variables which are ordered in time. So we have this t is equal to 1 to 8, 1 to let's say k. And what we are trying to understand over here is that what are the factors which is affecting the prediction of xt. So xt over here is, so let's say delta 0. So delta 0 is obviously my intercept term plus delta 1 xt minus 1. The second is delta 2 xt minus 2. Like this, I will have it till k. Delta k xt minus k. Right. So, so obviously one of the set of the factors are the historical or the lagged values of that series, right? So it basically says that the the asset price, the price of an asset will be explained by the historical prices of that asset itself. So over here, what we have is xt minus k, right? So when I say, so these are the historical values of the asset price. The historical values of X. The historical values of X, right? Now, when I'm looking into these historical values of X, now the question that comes out over here is that is it only the historical values? The answer is no. You can have shocks or historical random shocks, which the impact of which has also stayed in the prediction series, in the series of the prediction. So when you are trying to predict that series, so that part of those impacts have stayed down with you in the data, in the model, and so on, right? So one of the questions that we need to raise over here is that it's not a good idea for us to only look into these values. Now, it can also be the case that it's only the lag values of the series which impact the price, which impact the values of xt, but it could also be the case that it is the historical values of the historical errors or the shocks, the random shocks, which could have impacted these values as well. So over here, the second set of factors which impact it are, so let's say I'll put it at gamma t minus 1 plus gamma 2 let's say gamma q x t minus q. T minus q plus a random error term ut, where ut follows a normal distribution with mean 0 and a variance sigma square. So this is the second component. So the second component which can impact them are historical shocks. So this part is known as the historical shocks. These are the historical shocks. So we have these two approaches, right? So one is the historical values of X, and the other are the historical shocks. Now these two are the core component which can explain the the future values or the forward looking values of x. Now the question that again comes out over here is that when you are doing this prediction, which is the one, is it always necessary that the historical values of x predict x, impact xt, or the shocks express, or it can be a combination of both? So it can be a combination of both. So this component of this is where you have your historical values of x explaining xt. This is known as the autoregressive processes. Known as the autoregressive processes. Known as the autoregressive processes. This is known as the autoregressive process. And this part is known as the moving average process. Is a moving average process. The moving average process. Moving average process. So on one hand side, we have the autoregressive process, and the second is the moving average process. Now, one of the important things which we kind of talk about over here are that that your so the time series can be a mix of these two, or it could comprise of just these two. Now there are perfect memory models, long distance memory models, short memory models. So we will come across all those variations, but at the crux of it, this is what a time series is composed of. And this UT that we are talking about over here, so this is your random error term. So this is the random error term. The random error. The random error term. Now, on one side, you have a historical, so you have the autoregressive process, the moving average. Now, the question is that how do I boil down to the optimal process? Right? So, the components comprising autoregressive and the MA process will be known as the data generating process of the time series, and we use that model to keep on our predictions or to perform our predictions. Fine. So now the next question that comes out over here is, okay, so now the question is that what are the assumptions, what are the properties of these models, right? So what are the key properties? So one of the most important properties which we need to look out for a time series model is the property of stationarity. Is the property of stationarity. The property of stationarity. So what is this property of stationarity like? So the property of stationarity is that when we are trying to predict time series data, or when we are trying to perform time series predictions, what happens is that you have a long history of data along with you, right? So you have a very long history of data, and that data does not help us. So so that so even within that data, right? So there are different kinds of temporary tendencies which get which get which gets into the time series data, which affects the prediction. Right. Now, while we are trying to do a prediction, we cannot keep those temporary components into the predictions, because the prediction has to be done for the entire time horizon. So what we need to do is we need to temporarily take out those predictions, right? And then what we need to do is, once we have done the prediction, in those temporary times, we need to just add back those predictions, those impacts because of those effects, right? So what are those temporary predictions? What are those temporary components that I'm talking about, which creates which can create volatility in your predictions, which can make your data non-stationary in nature? Yes, Padmini, please tell.
See, can you just repeat the concept of,
Padmini, I cannot hear you.
can you please repeat that stationarity?
Yes, I'll repeat. Okay. So let's say I am trying to predict a time series which is like a sales time series. I'm trying to predict, okay, how is it that the garment section sale for Shopper Stop will be looking like in the next 12 months. And I'm using, let's say, the last 36 months of data, and I'm kind of trying to predict that record. Now, when I'm trying to make these predictions, let's say for the Indian market, or for a certain retail segment, what what would happen? You would expect, a surge in the temporary surge in the sales, or in the volume of sales at typical times of the year, right? So there will always be a seasonality impact. So let's say I am using data from 2016 till 2019 to make the predictions for 2020 and for the next year. So during the October, November months of every year, we would see that the sales spike up, and that impact gradually wanes down after December, in the month of Jan and Feb. So, so those temporary tendencies, some sales are a part of the average business, and some sales are triggered by certain part of the sales is triggered by the festivities around, right? So that's a very seasonal stuff. Now then, when you have stock clearance sales, so those are the time when the sales surge up. Now, when I'm making a prediction for the month of May, I need to adjust my predictions for those temporary peaks which has happened. Now, those temporary peaks are there because of the existence of certain temporary events, and that is where, and it is these temporary events which tend to make the time series non-stationary in nature. They tend to impact temporarily raise the mean sales, and then the sales again go down. So as a result, the mean becomes very non-constant or fluctuating over a period of time. However, when we try to predict the data, we should ensure that the mean and the variance of the data more or less remains unchanged throughout the different time points where we are computing the the products, right? So if I take out different subsamples from chunk of time and I should calculate the mean, I should get more or less a similar kind of a mean. Yeah, the mean will, in reality, there will be certain ups and downs, but that will not be a major up and down, right? So what we need to do is we need to ensure that the mean more or less remains unchanged throughout. Now, in order to make this mean remaining unchanged, what we need to do is we need to make the data stationary, because it is the existence of these temporary factors like seasonality, festivities, which occur at parts of the seasons, when that reflects into the retail sales, right? But that effect cannot be retained back for long when you are trying to make your predictions. So this is something that needs to be taken care. Now, removing these temporary, once you remove these impact of these temporary components or these temporary fluctuations from the data, so then you will obviously reach a long run. So you'll get to see that the overall mean over the different points of time will be more or less stable, because the business fundamentals do not change overnight, right? So even if you have new sales strategy in place, then that takes time to realize. So obviously, yes, the the mean sales that Shopper Stop now has compared to 10 or 15 years back will be different, no doubt on that. But if I take the last 2 to 3 years of sales, the mean of the long run average should be more or less constant, and all the mean should be around the long run average. Now, if there are abnormal spikes which are happening, then the challenge comes out. Then the challenge that comes out to us is that we would not be able to make a very reliable prediction, because if that seasonality impact is not segregated out separately and it is included in the data and you do the prediction, so it will tend to over predict your sales for the months when you do not have that effect present. So basically the sales prediction for May and June or April will be inflated much more than it should be. So in order to take the predictions as close as possible to the actuals or the actual realization, so therefore those tendencies need to be taken care of. And removing these tendencies, treating these temporary impacts and segregating them out from the long run fundamental trend of the time series is known as making the time series stationary. And because these impacts are temporary, we say that it temporarily cause the mean to increase and fluctuate, and hence that time series is said to be a non-stationary time series, right? Is that clear for me? Did you get that? Okay. Perfect. Fine. So the stationarity or the objective of stationarity is to adjust for temporary fluctuation tendencies in them. Adjust for temporary fluctuations in them. temporary fluctuations. Now, what are the factors which causes these temporary fluctuations? So one of the key factor which causes this temporary fluctuation is trend. Trend. The second set of factors that we need to look into is seasonality. Yeah. So as I was saying, for trend, seasonality, the third being cyclicality. Now, cyclicality as a matter of fact will be becoming a concern if you are using a data which spans over a whole business cycle. That is, if you're using for let's say 10, 15, or 20 years of data, then you can actually see an element of cyclicality involved into it, right? Otherwise, if you're using a short-term data, right, let's say 2 to 3 years of data, daily data, monthly data, the cyclicality as a factor will not be seen because it's a long-term factor. Right? So if you're using a data, let's say 10 years daily data or 20 years, if you're using data from let's say 1990 onwards to 2019, so then you will get multiple events where the GDP and the macro variables have been impacted because of cyclicality. Right. Now let's say you're using sales data. So over there, in that case, the sales information will be something which is which you need to take care of. So then seasonality will be a more dominant factor. But these are the three key factors, right? Now another factor is something which is, but this is something which we cannot really control for, but it creates a non-stationarity in the data, and that factor that we are talking about over here is a erratic factor. So let's say some market crashes has happened, had happened. Now, if it's an erratic factor, we cannot do anything about it. We just cannot do anything about it if it's an erratic factor. However, we would, so then the data treatment needs to be done, and we need to remove that from apart from the data and then take data after that. Now, let's say sudden market slump had happened. Now, whatever had happened, you cannot solve for that. You cannot treat that part. It's a feature of the data. So we use that data after the slump went, and then we look into it because that would have created a total change in the trend. Now, now let's see what challenges each of these can be posing for the data. Now, trend. Now, trend will be creating an element of non-stationarity in the data depending on whether it is a temporary trend or whether it is a permanent trend. Now, if that data is a temporary trend, right, if it's a temporary change in trend, then it will have a temporary impact on the mean and variance on the moments of the data, right? And there you will see that it generally kind of falls off, right? So after the trend is over, the data drops off. On the other hand, what you could do over here is the trend. So the next part that we have over here is the permanent change in trend. Now the permanent change in trend often is, so you know that how to treat this permanent change in trend is easier, because once you observe a permanent change in the long run trend has happened, you just take the data with the newest trend. So the data from the older trend is not really included. So that in that case, permanent change in trend is easy to identify and take it. But however, if a trend had suddenly come up and then gone down, then you cannot, then you have to treat it or remove that impact of the trend. And whenever you expect that trend to come back, or even if you expect it to ever come back, then you put it back. So without trend, with trend, and you look into the different set of values that we have with us, right? So this is one of the cases. Now the next part that we have over here is seasonality. Now seasonality is something which always creates a non-stationarity, and it needs to be treated. So over here, one of the important things is that we need to identify, right? We need to identify a trend, and then we need to treat it. So this is where the question is: identify and then treat it. Identify and treat it. The next thing that we have over here is the cyclicality. Now this is so this will be relevant only if a long run data is taken. If a long run data is considered. Right. And erratic trend is something which we really cannot help about anything except from choosing vintages and remove such that that erratic shock or that thing doesn't really have a impact on the data. Right. Let's say a war, or some so say a war period, or some natural calamities like corona. This is a typical case of an erratic event actually impacting all the entire time. So if you look into the whole long time series, let's say 30 years down, 20 years down the line, or 10 years down the line. So this is 1 year where you will see your time series is ruling, and you have to accept the fact that if that period is there, so your model will be under predicting or kind of over predicting during this year, if you are actually choosing a long horizon of the data. So you cannot actually incorporate this, or you cannot. So basically it's just a scenario that you have to always take into account, that without this would have been the prediction. If it is there, then this is what the prediction looks like. So there is a sudden jump. So all the macro variables have been impacted and their time series have been impacted. So all time series models which were into place, I believe they will also be badly impacted by the existence of this pandemic situation. Right. So so these are the factors which needs to be there, so while you choose to predict or to develop a certain model prediction. So this is something that, this is the very basic. So the first thing that we need to talk about under identify is that what is it that this stationarity would, or what is it that we need to do in order to ensure that the time series is stationary. So before that we need to address what is stationary. Now this stationarity creates, and so as we saw, stationarity is nothing but it creates a temporary change in the mean and the variance of the respective time series. Right? So any questions up to this point? Hello. So now the next question that comes out is, so the next way we need to identify is that whether time series is stationary or not. But before that, there are a set of validation checks that we need to do. So the first question is that I would do a stationarity analysis if the time series is non-stationary, and if I decide to go ahead with the time series analysis. So the first question that comes out over here is, how do we know whether a particular on a data that a time series analysis needs to be done? So how do we identify that a time series model needs to be developed? So what are the checks? So whenever if I try to like kind of develop a time series model, I need to identify that the time series model needs to be developed. So how do we identify that a time series model needs to be developed? Time series needs to be developed. That it needs to be developed. So over here, what we need to do is we need to identify those validation checks, right? So what are the validation checks that we will do? So what are the statistical tests that we need to do? So this will be a set of statistical checks. Now, once we identify and we justify, right, that the statistical tests, that certain statistical tests needs to be done, right, then what we would do is we would talk about, so once we have identified this exercise, the next question is that we need to identify whether the time series is stationary. So that's where the next question comes in, is how do we identify stationarity? We identify stationarity. Now, when I talk about identifying stationarity, the next question is what are the statistical tests? Identify stationarity. So how do we identify stationarity? So the test to identify stationarity over here is the augmented Dickey-Fuller test, or as we call it, the famous ADF test. So over here, we need to understand what the ADF test is, and we also need to understand the concept of ACF, which is a autocorrelation function, and the concept of a partial autocorrelation. concept of a ACF and a right. So these are the next set of checks that we need to do, right? And all these will be the base, all these will be the statistical tests, right? So we need to understand that what are the key tests that we need to perform for first to identify whether a time series model can be done, what would be the statistical basics, and then given that the time series model needs to be developed for our data, the next question will be to understand how exactly is it that the stationarity will be identified, right? So these are some of the questions that we need to address, right? So this is the portion that I will be discussing tomorrow. I'll not start with the statistical tests. What I suggest to you is that the recording will be ready in the next 10-15 minutes time. So, or in the next half an hour. So after that, just go through this, right? Just revise this and brush up the and just revise the testing hypothesis portion for tomorrow's discussion, right? So we'll start talking about all the key statistical tests and their frameworks. So over there, we would need those testing hypotheses and the concept of statistics, p-value, level of significance. So I would suggest you to go through this recording, today's recording, and just brush up those concepts so that we can start off with the statistical discussion in tomorrow's session, right? Okay, and Padmini, can we do the session tomorrow in the morning? Let's say 11:30 a.m. to 1 p.m., something like that. Perfect. Then we'll have the discussion 11:30 a.m. onwards. 11:30 to 1. Thank you.